Hi, my name is Trevor Hollingsworth. I'm one of the engineering instructors here at the Career Center. I teach, among other things, the Introduction to Engineering and Design class, which is the freshman level class. The class runs for the full year. You meet every other day for one block, which is either the chunk of classes that you have before lunch or the chunk of classes that you have after lunch. What do we do in the class? Well, as the name implies, we're focused on the field of engineering generally. So it's an introduction to the kinds of jobs and the kinds of work you might do in the field. More specifically, we're focused on design work. So how do you take an idea, get it from your head onto the page or into somebody else's head, which is the real trick. As tools to accomplish that task, we are learning how to better draw out our ideas, how to better document our ideas, and teach students how to use a 3D modeling program that allows us to simulate our ideas in a virtual world, more easily change and manipulate them, and then create documentation for them that helps another person understand. Also, if we've got a 3D model, then we can 3D print, which is more fun, honestly, than producing the documentation. So again, big focus on design, specifically 3D modeling and 3D printing. What specific projects do we do? Okay, we start with a puzzle cube project, right? And the puzzle cube is made of individual small wooden blocks. We're designing small pieces that are meant to fit together to form a cube. Looks kind of like a Rubik's Cube, does not function like a Rubik's Cube, but that's the best way I can describe it. Why do we start with that kind of project? Honestly, because it's an easy thing to draw. It's a lot of rectangles and squares, and it's an easy thing to model in our 3D modeling program. It gives us a chance to work through a design from start to finish, produce a prototype, a real world thing, and it's a satisfying project. We have to move on to more complicated things from there. One of the more complicated projects we do, give me a moment to share my screen, is a reverse engineering project using Legos. Actually, during the year, we do a lot of reverse engineering. What I'm trying to help students understand how to do is document a real world object so that they can recreate it. I like Lego because of the patterning that's involved in Legos and because we have a lot of them on hand. So I can put them in students' hands. We can use our measuring tools to get information from the product itself. And then we can try and reproduce it virtually in our 3D modeling program. Once we've got it reproduced, that lets us do things like create documentation. I'm in a student file, so I'm working to get to this student's documentation of their project. This is one of the bits of documentation that was put together. This is how you would assemble this particular Lego construction. You'll notice that it seems a lot like the instructions you might find in an actual Lego product, and that's because the real products are made in the exact same way. Again, this is not hypothetical things we're learning. These are real world applications that hopefully can transfer to later jobs. So in addition to Legos and the puzzle cube, one of our other big projects is a putt-putt project where we are designing miniature golf courses and then producing them in real life. So this is a miniature golf course. This is a 3D printed model from one of the designs. So the idea is a student would take this model and the other references they create, use it to create their real world objects. This course is actually going to be 2 feet by 4 feet. It's going to be made out of plywood and 2x4s and PVC. Speaking of, gives us a chance to use some tools, which may or may not be a thing that you have experience with. Don't worry, haven't lost anybody yet. If you are worried that you're not going to be good at some of these tasks, I agree, you're probably not going to be good at these tasks. That's the whole point of taking the class, is so that you can fail in a safe environment, not fail in terms of grades, just fail in terms of a thing that you tried to do in that moment. We can work through the failure, figure out what went well, what didn't go well, what we can adjust for the next time, and typically we're going to try it again. In the design world, it's called iteration, where we try, improve, try, improve, try, improve. Again, having the whole year and having a 2.5-hour block of class really lets us dig into projects and learn through trial and error in addition to learning in an academic sense. All right. How do you get here? Get down to some of the logistics. Most people get here by first going to their home school and then riding the bus. And so if you choose, your schedule doesn't have to be, your arrival and dismissal schedule doesn't have to be any different than what you're used to. You go to your home school in the morning, and rather than going to your first class, you get on a bus, you ride to us. Or maybe right after lunch, you get on a bus, you ride to us. When class is over here, you get back on the bus, takes you back to your home school. Parents would pick you up there just like normal. If you're taking classes with us as a junior or senior, you are allowed to drive yourself here. Freshmen and sophomores are not. That is board policy. Apologies for that, can't be helped. What you can do as a freshman or sophomore, or I suppose a junior or senior, is have your parents drop you here rather than taking you to your home school, say in the morning or right after lunch. Could also pick you up here. So that is a convenience. What would you need for the class? Really very little. I'm expecting you to bring a pen or a pencil so that you have something to write with, but we're supplying you with the other things that you would need. Prerequisites, pre-knowledge, nope. None of that. The intro class covers everything. We assume that you know nothing about engineering when you come in, and we work from there. Do you have to commit to the program? Well, let's say you're not sure what you're going to do with the rest of your life, and this class seems interesting enough to try, but you're worried about a commitment. We are not asking you for a commitment right now. After the freshman year, you're going to get a chance to look at the other programs we have on campus. Sophomore year is traditionally when we start everything else that's here. If you have decided at that point that engineering is not for you, you'd rather go into the radio video program or the law enforcement program or the biomedical program or any of the other great programs that we have on campus, fine. I'm going to wish you the best of luck, and hopefully you'll drop in and see me. If you choose to go on to other engineering classes, we do have a slate of classes ranging from digital electronics to computer integrated manufacturing to principles of engineering, which is a mechanical design and physics related class, to senior level classes where you are either working on your own design projects for the semester, kind of directing your own learning, or if you have established the right reputation for yourself and you do the legwork, there are internship and co-op opportunities for seniors that could result in you both getting a paycheck and getting credit for a class, plus the real world experience and the contacts that come with that kind of work. If you have questions about our program, please feel free to contact us here at the Career Center. My email address is thollingsworth@andersonctc.org. You could also contact our guidance department. They could give you more information about our programs. If you're interested in seeing our facility, I would encourage you to contact either myself or the guidance department. We could set up some kind of tour for you after hours, most likely, because of the restrictions that we're dealing with this year. But we can certainly get you in to see what you would be dealing with in the next year. Usually we have kids come in to see the facilities in person because honestly, they're impressive. We have a lot of equipment on site that is used in the real world that students might not have access to at their own high school. Gets them experience in the field, gets them experience using equipment and tools that are relevant to the field that they want to explore.